Welcome back, guys. Quick shout out to Kaylee, Catherine, Dan T, and Ariella. I think we're almost done with the shout outs, but I think I might have one more. Anyway, this is a really quick one. We're using double angle formulas now. Again, you will have, I'm giving you this sheet today. So before you actually view this, you should have the sheet in your hand. If we look at the sheet though, I'll bring it up real quick. These were all the adding and subtracting ones, and now the double angle formulas are down here. Notice how cosine of 2x has like 3 different ones. We're going to use this information to prove our, we're going to confirm the double angle identity by splitting it apart, okay, using the sum and difference identity. So, let's look at our note sheet. And I have sine of 2x is equal to 2 sine x cosine x. So it says to use the sum or difference formula. So I have to go back here and think about how can I write this as a sum of two things. Well, I can rewrite this as the sine of x plus x. Because then, because x plus x is 2x. So there we go. Now I can go to my identity over here and go, well, what is sine of x plus x? It's sine, cosine, and cosine and sine with a plus between them. Okay, so this turns into sine x cosine x plus cosine x sine x equals 2 sine cosine x. And sure enough, they're the same thing. So you have 2 sine x cosine x equals the same thing. Now, you will have a few of these in your worksheet. Just use the correct sum formula for cosine. But most of the time, all you're doing is splitting this apart and then using the correct formula that you need to use. Alright, so that's that. That's an identity using our double angle and sum and difference formulas. Now, we're going to use these formulas also to find the exact values of sine of 2a, cosine a, and tangent of 2a, if a terminates in the given quadrant. So quadrant 2, sine is 11 over 61. So first thing I'm going to do is draw my triangle. There's quadrant 2. Sine is 11, the height, over 61. I need to find this piece down here. Pythagorean theorem. When you do this, you get x is equal to 60. However, make sure you know what quadrant you're in. We are in quadrant 2. So, this is negative 60. And here then is a. Well, that's the reference of a, actually. Technically, a is over here. But alright, so now we have to just use our formulas to find our answers. So first thing I'm going to do is sine of 2a. Is the formula of that we just did up there is 2 sine a cosine of a. Okay? So when you plug these values in, you get 2. The sine of a is 11 over 61. And the cosine of a is negative 60 over 61. So when you multiply that out, you get the fraction. Please leave it as a fraction, negative 1320 over 3721. So the sine of 2 times the angle is that fraction. Exactly. Now, cosine of 2a, there are 3 formulas we can use. There's cosine squared minus sine squared, and then there's the other 2 where you plug in either you change the cosine squared to sines or sines to cosines. I'm going to just use cosine squared minus sine squared. Alright, so I get cosine is negative 60 over 61, quantity squared, minus 11 over 61, quantity squared. When you do that math, you should get 3479 over 3721. Alright, so that's sine of 2a, cosine of 2a. Here is how you do tangent of 2a. Yes, there is a formula for it. However, don't use it. It's a waste of time. Here's what you do instead. You guys should remember, hopefully, since we've been doing this so much, the tangent of anything is equal to the sine of the same thing over the cosine of that. So here's what you do. Tangent of 2a equals negative 1320 over 3721 divided by 3479 over 3721. When you have a fraction divided by a fraction, you flip this and multiply. So this becomes 3721 over 3479. These cancel. So the tangent of 2a is equal to negative 1320 over the 3479. And you didn't have to do that big formula on the double angle formula sheet. So it's much easier just to do that. And if you get the wrong answers for these but use this, then I'm fine with that. Just be careful with that though. Alright, let's do one more with this. Cosine of cosine of A, it's not alpha, is in quadrant 3. I draw my triangle. Here it is. So this is A, but the reference we'll put there. Negative 3 over 5. Hopefully you guys know your triples. It's a 3, 4, 5 triangle. You could do Pythagorean theorem, but you don't need to if you know it. This, though, is negative because it's in quadrant 3. So, find all the 3. So again, we're going to go back. Sine of 2a is equal to 2 sine a cosine a, which is equal to 2 times the sine of a is negative 4/5. The cosine of a is negative 3/5. So what do we get there? We get 24 over 25. All we're doing is plugging in the sine of a and the cosine of a because we know those based on the triangle. And then using our formula to figure out what the sine of 2a is. Cosine of 2a, same thing. I'll do cosine squared minus sine squared again, because that's one of the formulas you can use. You can use any of the 3 though. What was cosine? Negative 3/5 squared minus negative 4/5 quantity squared. Okay. And then when you solve that, you get negative 7/25. Okay. So that is our cosine of 2a. Remember tangent, we just divide them. It's sine over cosine. Sine was 24/25 over cosine, negative 7/25. And we flip it and multiply. So when I flip this, I turn it into 25 over negative 25 over 7. The 25's cancel, and tangent of 2a is equal to negative 24/7. And then we're done. Pretty easy day. That's all we are doing for today. This worksheet should be a breeze. Alright, and you guys then are done.